Yesterday we have seen the definition of Fourier transform, and correspondingly we have seen one problem, and one problem is given for your exercise. Right. And today we will also continue with the same kind of problem with the help of the definition of Fourier transform. Help of the definition of Fourier transform, I'll see some additional problems. Yes, take the third problem. Find the Fourier transform of f of x that is equal to 1 minus x square, 1 minus x square for mod x less than 1 and 0 for mod x greater than 1. 0 mod x greater than 1. Just like a first problem here, find the Fourier transform of f of x equal to 1 minus x square for mod x less than 1 and 0 for mod x greater than 1, and hence show that integral 0 to infinity sin x minus x cos x whole divided by x cube, sin x minus x cos x whole divided by x cube into cos x by 2 dx is equal to 3 by 16. For here, first you have to find the Fourier transform of this function. Based on the result obtained about the Fourier transform of that function, you have to identify the value of the integral. That integral value is equal to, you have to show that 3 by 16. 3 by 16. Yes, first write the, so in the solution write the function f of x here. Given f of x equal to 1 minus x square mod x less than 1 or minus 1 less than x less than 1. Mod x less than 1 means minus 1 less than x less than 1. Mod x greater than 1 means 0. Mod x greater than 1 means already we know that more than 1 to infinity, because of modular symbol less than minus 1. Minus infinity less than x less than minus 1. Both the things it is possible. Then by definition of Fourier transform, we can write Fourier transform f of x, Fourier transform f of x equal to 1 by root of 2 pi, definition only, minus infinity to infinity, f of x e power minus isx dx. F of x e power minus isx dx. Okay, right. Now instead of f of x, you have to substitute here, but it can be split as minus 1 to 1, minus into minus 1, minus 1 to 1, and 1 to infinity. We can split into two intervals here, minus into minus 1, minus 1 to 1, and 1 to infinity. F of x e power minus isx. One by root of 2 pi. Already you know that first and the last value is 0 here, 0 and 0. Minus 1 to 1. F of x is defined as 1 minus x square. Minus 1 to 1, it is defined as 1 minus x square. Remaining things it will be 0. Or middle part 1 minus x square, remaining part 0. First and the last part it will be 0. Okay, right. Yes, as like therefore you can get minus 1 to 1, 1 minus x square e power minus isx dx. Yes, as like yesterday's discussion here, it is even function. Therefore, in order to write integrals in the symbol form, we can convert e power minus isx as a cos x minus I sin sx form. Cos x minus I. Remaining part we can try yourself here. It will be very simple project, just integration only. You also try. I will also show that here. Okay. 1 by root of 2 pi integral minus 1 to 1, 1 minus x square, cos x minus I sin sx dx. Okay. This is even function. Already cosine is a even function. Cos function is a even function. Therefore, even product is even. This is even. This is odd. Therefore, totally it will be an odd function. If it is a even, you can write 2 into 0 to 1, because minus 1 to 1, 0 to 1. For odd function, it will be 0. So 1 by root of 2 pi, 2 into integral 0 to 1, 1 minus x square cos sx dx plus 0. root of 2 pi pi 0 to 1 1 minus x square cos x dx. Right? Then can apply Bias product of two functions here. Apply integration by parts. 1 minus x square. It will be sin s by s. Integration will be sin s by s. 1 minus x square you can keep as it is here, and minus formula minus differentiation of this factor minus 2x, integration of this factor minus cos x by one more s, already s is there, s square, then plus minus, then plus formula plus differentiation of first factor minus 2, integration of second factor. Already a minus is there, so cos x is integration is sin x minus sin x by one more s cube, then plus minus plus, then formula minus definition of first factor 0. Definition of first factor 0. Totally your limit will be 0 to 1. Your limit is 0 to 1. 0 to 1. Okay, right. Then the limit is for the variable x here, therefore we take s outside here. Here 1 by s you can take it outside here, minus minus plus, and here 1 more minus 2 by s square outside here, here minus 2 by s cube outside here. You take it like that here. So I will take the unnecessary things outside of the limits here. 1 by s, the second term minus 2 by s square, and third term 2 by s cube, 2 by s cube. The limit is only for x only here, therefore 1 minus x square sin s 0 to 1 x cos s 0 to 1 sin s 0 to 1. When you apply the limit here, 1 minus 1 0, sin 0 is 0, totally 0, minus 2 by s square. Now apply limit 1 here, 1 into cos s, cos s. Applying 0 here, 0, 0 into so on, 0. That's 2 by s cube. When applying 1 here, sin s. When applying 0, sin 0, 0. Or this is totally 0, therefore only these two terms here. Therefore, in these two terms, I will take s cube outside here, 2 by s cube outside, and sin s. And here s cube is taken, or minus s cos s, minus s cos s. For this is your Fourier transform. Fourier transform is given by 2 into square root of 2 pi, or 2 into square root of 2 pi, sin s minus s cos s by s cube f of. This is Fourier transform. Fourier transform of the given. Okay? Fourier transform of the given function. F of s. F of s. All of you noted down?
Yes.
Okay. Okay. Right. Now you see the deduction part here. Deduction here you are applying sin s minus s cos s by s cube. The f of s here. The deduction also sin s minus s cos s by s cube. Already we obtained result. But here in the deduction, instead of s, here x is there, x sin x minus x cos x by x cube. So totally the same type of function, but extra term is there here. There's no problem here. Therefore, that f of s you have to take it inside the integration. This is possible with the help of inverse Fourier transform. For adopt inverse Fourier transform further. For deduction by inverse Fourier transform, by inverse Fourier transform, we have f of x equal to inverse Fourier transform definition 1 by root of 2 pi integral minus infinity to infinity f of s e power isx plus isx, that is very important, e power plus isx ds. Everything is with respect to s only, s. F of s e power isx s ds with respect to s. Yes, f of s just now we identified as 2 into square root of 2 pi pi sin s minus s cos s by s cube. Yes, f of s is here. This is f of s, 2 into square root of 2 pi pi sin s minus s cos s by s cube here. Yes, here is also 2 into square root of 2 pi pi sin s minus s cos s by s cube. And additionally, we have e power isx, extra term is e power isx ds. So this root 2 and root 2 get cancelled, root 2 and root 2 get cancelled here. Therefore, we can get just 2 pi and root pi into root pi, 2 pi pi. And again, for our convenience, we convert this as a cos sx plus I sin sx form. Cos sx plus I sin sx form in order to get even and odd function area. Even and odd. Remaining function as it is, sin s minus s cos s by s cube. Now integration is with respect to s, and also limit is minus infinity infinity, minus infinity. Totally you can check about its nature of even and odd function idea. Even and odd function idea. First of all, you consider this function here, whether it is even function or odd function here. You change s by minus s, sin or minus theta minus sin theta, minus you can get. Here s by minus cos or minus theta cos theta only. Here s by minus 1 minus you can get, 1 extra minus. Here 1 extra minus. If you change x by minus s by minus s, you can get extra minus. This extra minus and this extra minus get cancelled here. Therefore, again you can get same function. Again you can get same. Here extra minus, extra minus, extra minus. Again you can get the same function. Therefore, this is totally a even function. Even function. This is even already. Therefore, even and even and odd function. This is all odd function you know already. Sin is odd function. Therefore, you can get this is even. You can write 2 into 0 to infinity. This is odd 0 here. 0. Or you can write it as 2 pi pi 2 into 0 to infinity sin s minus s cos s by s cube into cos s x ds. Cos s x ds. Sin s minus s cos s by s cube cos s x ds. Plus 0. 0 is odd function. Working at 4 pi pi 4 pi pi integral 0 to infinity sin s minus s cos s by s cube cos s x ds. Right. Yes, further in the deduction, you can replace s by x, there is no problem here. Here, we need cos x by 2, that type of relation they are asking here. Cos x by 2, you see the question here. The question they are asking cos x by 2. Further that expression, we need cos x by 2 here. Therefore, what is the thing you can do here? You can replace s by x first here. S by x, that is okay. Sin x minus x cos x by x cube, that is okay. Here s by x, but here for this x, you have to replace 1 by 2 because we need cos x by 2. Already this is changed as a x. For cos x by 2 we need, therefore we put x is equal to 1 by 2. Put x is equal to x and x is equal to 1 by 2. X equal to n by 2 for both sides here. And ds equal to dx, and no change in the limit because of this substitution, no change in the limit. When x equal to 1 by 2, both sides here, x equal to 1 by 2 and 4 pi pi 0 to infinity, you change here s by x here, sin x minus x cos x by x cube, here already s by x, x cos x, and x by this x by 1 by 2, but cos x by 2 dx. We are getting that relation. Now we are in need of f of x at x equal to 1 by 2 left side here. Yes, your definition is f of x definition is 1 minus x square for minus 1 to 1. Minus 1 to 1. Otherwise, it's 0. For minus 1 to 1, therefore your x equal to 1 by 2, x equal to 1 by 2 definitely lies between minus 1 to 1. Therefore, you get the definition of 1 minus x square. Okay, you have the functional value 1 minus x square for x equal to 1 by 2. Then you replace x equal to 1 by 2. X equal to 1 by 2. Therefore, you put a 1 minus x square x equal to 1 by 2, 1 minus x square x equal to 1 by 2, and 4 pi pi del 0 to infinity. Right side no change, right side no change as it is here. This is 1 minus 1 by 4, 1 minus 1 by 4, 4 pi pi, no change of right side, no change of right side. It will be 3 by 4. Then you cross multiply this here, this 4 pi pi left side here, 3 pi pi 16, 3 pi pi 16. Right side same integral here, 0 to infinity sin x minus x cos x by x, sin x minus x cos x by x, cos x by 2 dx. Okay, right. Cos x by 2 dx. This idea we can get that. Okay, right. This is the result we need here. Yes, they are asking that is equal to 3 by 16. Yes, that value is equal to 3 by 16. Just use the definition and also inverse Fourier transform to identify the deduction part. Okay, deduction part. This is the idea. Right? I think all of you understand this problem. This is also very important problem. You should take another one, fourth problem. For all of you previous problem over. If I am moving fastly, you please tell that. Okay? Yes, fourth one. Find the Fourier transform of f of x equal to. Find the Fourier transform of f of x equal to e power minus mod x, e power minus mod x, and hence evaluate. And hence evaluate integral 0 to infinity, 0 to infinity cos sx by s square plus 1 ds. And hence evaluate what is the value of this integral cos sx by s square plus 1 ds. And a very important thing, because of this Fourier transform idea only, we can able to identify this type of integral value. Because 0 to infinity is limit. It is very tedious to identify. You see the previous problem. It is very tedious to identify this type of integration limits values here. But with the help of Fourier transform technique, we are identifying. And here is also evaluation of this type of integral 0 to infinity cos x by s square plus 1 ds. Very tedious, but this type of integral we can solve with the help of contour integration also. Already you maybe studied this type of integral in the contour integration the previous semester again. Otherwise you can solve with the help of Fourier transform. But previous type of problem you cannot solve with the help of contour integration, only Fourier transform only here. And here both the things possible, the contour integration and the Fourier transform possible, that you are going to identify. But if you want to apply Fourier transform technique here, but you have to know about that specific function here, specific function, then only you can easily identify. Yes, here specific function is given as f of x equal to e power minus mod x, e power minus mod. By definition of Fourier transform, you write f of x equal to 1 by root of 2 pi, 1 by root of 2 pi, integral minus infinity to infinity, f of x e power minus isx dx. Integral minus infinity to infinity f of x e power minus isx dx. And Fourier transform of e power minus mod x, you replace f of x equal to e power minus mod x, e power minus isx. This is even function, e power minus mod x, therefore you can split here e power minus isx as a cos sx sin sx, cos sx minus I sin sx. You can same idea, split that. Again this is even and this is odd function here, therefore you can write as 2 into 0 to infinity e power minus mod x cos sx dx, e power minus mod x cos sx dx. This is 1 by root of 2 pi, 2 0 to infinity is 1. Root of 2 pi pi you can convert. Because 0 to infinity is a positive range, therefore no need of modulus symbol, no need of modulus symbol. We can write e power minus x cos sx dx, e power minus x cos sx dx. Because 0 to infinity is a positive range, no need of modulus symbol. Now your work is that you have to evaluate this integral. One is exponential, one is cosine function. Algebraic and so on means you can adopt that Bernoulli's formula directly here, but here this result already you know that here, but it is also by integration by parts and also by reduction formula. That result you are getting here. What is the result? Integral e power ax cos bxt. You know the result of exponential into cosine function. Similarly, exponential sine function also you know that. Exponential e power ax cos bx dx is equal to e power ax by a square plus b square. A cos bx plus b sin bx. A cos bx plus b sin. What about here? A is minus 1 and b is yes. A is minus 1, b is yes. B is yes. So substitute in this known result, known formula, root of 2 pi pi e power minus ax, e power x, e power minus x, e power minus x by a square plus s square. A square is minus 1, a is minus 1, and b square is s, minus 1 square plus s square, minus 1 square plus s square. Then a cos bx, a is minus 1, minus cos sx, a cos bx, plus b sin, b is s sin sx. S sin sx. What about the limit? Limit is 0 to infinity. Limit is 0 to infinity. Okay, right. When applying first limit here, e power minus infinity, you apply first here, that is totally 0. E power minus infinity tends to 0 here. Therefore, this part totally vanishes. Then apply second limit, minus second limit, e power 0, 1, 1 by s square plus 1, cos 0, 1, sin 0, 0. Therefore, e power 1 by s square plus 1 into minus 1. You apply second limit. First limit is totally 0, and second limit 1 by s square plus 1, minus 1 plus 0. Minus 1 plus. Therefore, minus minus plus here you can get root of 2 pi pi 1 by s square plus 1 f of s. This will be Fourier transform. Therefore, take it as a f of s, function of s. Now, what about the deduction here? As 1 by s square plus 1, yes, in the deduction 1 by s square plus 1 is here. Therefore, obviously, as usual, you take inverse Fourier transform. Or by the definition of inverse Fourier transform, what is the definition? F of x equal to 1 by root of 2 pi, integral minus infinity, f of s e power isx ds. F of s e power isx ds. Okay, right. Now substitute f of s. F of s is equal to root of 2 pi by 1 by s square plus 1, root of 2 pi pi 1 by s square plus 1, and here you can split it as cos sx sin sx. Root of 2 pi pi 1 by s square plus 1 e power isx. As usual, you can try yourself also. This is cos sx plus I sin sx, even and odd function you can split. This is even, this is odd function. Okay, right. Or f of x is e power minus mod x left side. Even function 2 into 0 to infinity, odd function 0 by even and odd function idea. Even and odd function. Yes, that's all. The question is that what is the value of the integral 0 to infinity cos sx by s square plus 1 ds. Yes, here is that 0 to infinity cos sx by s square plus 1. Here there is no substitution we require here. Directly you substitute here. Cos sx by s square plus 1 ds. So that is equal to, we are getting as a pi by 2 e power minus mod x. Pi by 2 e power minus mod x. Pi by 2 e power minus mod x. Okay, right. If you put x equal to 0 here, x equal to 0, can get it as integral ds by s square plus 1 0 to infinity, that is equal to pi by 2. Yes, obviously that result also you know that here. S by x by s by x is equal to 0. Integral dx by x square plus 1 tan inverse of x 0 to infinity. That idea can get, that should be pi by 2. That result you can get that. Okay, right. Suppose if you replace like this here, s by x, x by a, s by x cos x square plus 1 x by a. Then you can get cos ax by x square plus 1 dx is equal to pi by 2 e power minus r a. Pi by 2 e power minus r a. Okay. You can substitute if you necessary. You can substitute here s by x by a. You can get integral 0 to infinity cos ax by x square plus 1 dx is equal to pi by 2 e power minus mod a. That's also you can get it. That's not asked, but again, if you are interested, you can substitute many results. Okay? Yes, here you are using the formula as e power ax cos bx dx here. Similarly, e power ax sin bx dx means e power ax by a square plus b square. A sin bx minus, here you can get minus b cos bx. Reverse a sin bx first and then minus b cos bx. That type of result you can get. Okay? Right. This column over. If you understand, I think that. Yes. Here another one important problem, and you have to remember always this problem is very, very important, oftenly asked. Find the Fourier transform of f of x equal to e power minus a square x square a greater than 0. Find the Fourier transform of f of x equal to e power minus a square x square a greater than 0. F of x equal to e power minus a square x square a is greater than 0, and hence show that Fourier transform of e power minus x square by 2. Fourier transform e power minus x square by 2 is e power minus s square by 2. Same function, only variable only changed here, but function is same. Variable only changed, but function. After taking transform of this function, again you are getting the same function, means you can say that it will be a self-reciprocal function. That is, the next line that is e power minus x square by 2 is self-reciprocal under Fourier transform. E power minus x square by 2 is self-reciprocal under Fourier transform. Power minus x square by 2 is self-reciprocal under Fourier transform. Okay. Okay. Therefore, the transform of any function is itself, then you can say it will be a self-reciprocal function. Right. The solution given f of x equal to e power minus a square x square a greater than 0. E power minus a square x square a greater than 0. By definition of Fourier transform, you write the definition of Fourier transform. Fourier transform f of x equal to 1 by root of 2 pi integral minus infinity f of x e power minus isx dx. F of x e power minus isx dx. Therefore, instead of f of x here, e power minus a square x square, substitute Fourier transform e power minus a square x square 1 by root of 2 pi integral minus infinity e power minus a square x square. Instead of f of x here, e power minus a square x square e power minus isx dx. E power minus isx dx. But one thing is you have to remember here. You see the previous problem. It is also exponential. Previous problem also exponential, but it is a linear power x, and here is also x here. Linear power here. Therefore, you can easily use this formula e power ax cos bx. If you split even and odd function idea, you can use e power ax cos bx dx because of linear. But in the given now you have the problem of x square here. X square, it is not linear. In your problem, it is not linear. It is x square here present here. Therefore, you cannot apply that formula. Okay? You cannot apply that formula. Therefore, here we are not going to move by that even and odd function idea here because you cannot use that formula. Therefore, you have to you can club these two. Where it is also exponential, it is also exponential. Therefore, you can club these two. Therefore, here as usual, is ordinary way you proceed with that integral minus infinity e power minus of a square x square plus isx. You can club both the things, a square x square plus isx, both the things. You can club. Now, in order to evaluate this integral here, because it is x square and x term is present here, to evaluate this one here, you try to you consider this one as some a square x square here, x is here, If we treat it as some a square plus 2ab form, okay? X square and x, therefore a square plus 2ab form, a square plus 2ab form. If you treat it like a square plus 2ab form, what about a here? A is ax, a is ax. So in the next line either here 1 by root of 2 pi integral minus infinity exponential e power minus of, you keep minus as it is, a square plus 2ab dx. What about here? A is ax. A is ax. 2ab is what here? Isx. AB is Isx. A is ax, b, and Isx. Yes. For x and here you replace a is already ax here, therefore replace here and x and x will cancel. What is b now here? B is is by 2a. B is is by 2a. When you substitute like this here, what about a is ax, and what about b? B is is by 2a. You consider like this here, you can get this expression. Right. Now, for our convenience, this a square plus 2ab in the next line we write here 1 by root of 2 pi by integral minus infinity. This a square plus 2ab can also be written in the simplified form as a plus b whole square minus b square. As one extra b square is present, therefore you can remove that b square by subtracting that b square. For a plus b whole square minus b square. Right. Now substitute required a, b and relations. A is ax, b is is by 2a, is by 2a whole square plus sorry, here minus b square means b square is I square s square by 4a square. I square is minus 1, already here minus plus s square by 4a square. Because of this plus is I square is minus 1, over here already a minus, therefore s square by 4a square, okay, with respect to x. Now you see the integration is with respect to x. Here x involves, here x involves, but here there is no x. We'll take it outside here. This part you can remove from the integration. It is unnecessary inside the integration. For when you split that integral function here, e power x for one part and s one part here. Okay? This is x part and this is s part here. We take it separately. This minus you have to multiply. Minus you have to multiply. Okay? Right. But integration is with respect to x here, therefore you can easily take it outside of the integration. 1 by root of 2 pi integral e power minus s square by 4a square, take it outside of the integration, and only this part only integral. Exponential minus of ax plus is by 2a whole square dx. Okay? Right. Now again to evaluate this integral here, this is the x is the integration is with respect to x here, therefore x is a variable. Over here some addition of this will be treated as a constant here, therefore we take it as this as a y is equal to, let y is equal to ax plus is by 2a. What about here we are changing x to y, okay? We are converting x to y, therefore dy becomes a dx, this will be treated as a constant, and the dx correspondingly 1 by a dy. When x minus infinity, y is also minus infinity, x infinity, y is also infinity. No change in the limits. No change in the limits. Therefore, now substitute here. No change in the limit. This will be e power minus y square. Dx becomes 1 by a dy. 1 by a dy. For e power minus y square, 1 by a dy. Remaining part as usual. Left side, outside of the integral, the same relations. 1 by root of 2 by e power minus a square by 4a square. Same relation. Now you take this a constant a outside here, 1 by a root of 2 pi e power minus s square by 4a square integral minus infinity e power minus y square dy. Integral minus infinity e power minus y square dy. Right. Now you see this function is even function. If you replace with respect to y, if you replace y by minus y, the same function you can get here. You can get 2 into 0 to infinity e power minus y square dy. 2 into 0 to infinity e power minus y square dy. 1 by a root of 2 pi e power minus s square by 4a square, 2 into 0 to infinity e power minus y square. Okay. Then how can you evaluate this integral? That will be the next question here. How can you evaluate this integral here? E power minus, again, it's not linear. We started with it's not linear, therefore we can proceed by that way. Therefore again you are getting the not linear y square form here. But you can substitute, you can convert it by the substitution here, because of 0 to infinity negative exponential. 0 to infinity negative exponential. You can find it in gamma function. Gamma n definition is what? 0 to infinity negative exponential e power minus x power n minus 1 dx. If an integral is have this form, you can say that it will be a gamma integral. Gamma. Therefore, here also you can put like that here. I put y square equal to z. Y square equal to z. Obviously, you can get this type of gamma integral by the substitution. Right. For your next procedure is that y square equal to z here. Put y square equal to z. Then 2y dy is equal to dz. Then dy becomes dz by 2y, dz by 2y. What about y again? Y is root z. Y is root z. So now dy comes in terms of purely dz form, z form. Dy is equal to dz by 2 root 2 z. No change in the limit because y0, z0, y infinity, z infinity. No change in the limit. For outside of integration, same relations 1 by a root of 2 pi. For that integral equal to 1 by a root of 2 pi. E power minus s square by 4a square. Okay? 4a square into 2. 2 is outside. 2 is outside. 0 to infinity, no change. Here e power minus z. dy becomes dz by root 2 root 2 z. E power minus z. dy becomes dz by 2 root 2 z. 2 square root of z. This 2 and 2 get cancelled. Okay? Right. We take it into the numerator. Z power minus 1 by 2. Z power minus 1 by 2. Here. We'll take it as z power minus 1 by 2 dz. Remaining things are as usual. A1 by a root of 2 pi. E power minus s square by 4a square. Integral 0 to infinity. E power minus z power minus 1 by 2 dz. Okay? 1 by a root of 2 pi. E power minus s square by 4a square. Gamma integral definition, you know that again. Integral 0 to infinity e power minus x power n minus 1 dx here. N is n minus 1 form we require here. Therefore, here e power minus x, e power minus z, x power n minus 1, z power something, is x dz. So, we need a n minus 1 form here. For that, you can write this minus 1 by 2 as a 1 by 2 minus 1 form. Okay? 1 by 2 minus 1 form. Z power 1 by 2 minus 1 form. Right? 1 by a root of 2 pi e power minus s square by 4a square. 4a square. Yes, now it is like a gamma integral form. E power minus x, e power minus z, x power n minus 1, z power 1 by 2 minus 1, dx, dz, 0 to infinity. So instead of n here, 1 by 2 is present. Therefore, this is gamma n. Gamma n is 1 gamma 1 by 2. Gamma 1 by 2. Gamma 1 by 2. But everyone know that gamma 1 by 2 value equal to root pi. Gamma 1 by 2 value equal to root pi, root of square root of pi. So substitute square root of pi here. So the square root of pi and the square root of pi get cancelled here. For your answer for Fourier transform, e power minus a square x square is 1 by a root 2. E power minus s square by 4a square. E power minus s square by 4a square. 1 by a root 2 e power minus s square by 4a square. Come on. This is Fourier transform e power minus a square x square 1 by a root 2 e power minus s square by 4a square. Put a square, what about reduction here? Reduction is e power minus x square by 2. See the problem here, e power minus x square by 2. Therefore, here a square equal to 1 by 2. A square equal to 1 by 2, you can get e power minus x square by 2. A square equal to 1 by 2. So in the deduction, you have to put that a square equal to 1 by 2 in the above result. In the above result, therefore, we can get f of Fourier transform e power minus x square by 2. A square equal to 1 by 2 means a is 1 by root 2. 1 by root 2, root 2. A square equal to 1 by 2. 1 by 2, 2, 4, 1 by 2 can get e power minus a square by 2 can get. Root 2 get cancelled. So your answer will be same answer. F of e power minus a square, e power minus x square by 2 equal to e power minus s square by 2. So transform of that function is same function. Same function. Therefore, you can say that e power minus x square by 2 is the self-reciprocal function under Fourier transform. E power minus x square by 2 is a self-reciprocal function under Fourier transform. Fourier transform. It's very important. Here the problem, just you have to remember, this is only one place only. After definition, because of square, x square is present, we cannot move by ordinary way, even and odd function area. You cannot identify the solution. So you split the club that are both exponential, then you write it as a square plus 2ab form. Then further, as usual. That's all. The remaining things are by substitutions only. You can easily get that. And finally, you put a square by 1 by 2. You can get the answer. Okay. If you are not only Fourier transform, Laplace transform also, if the transform of any function is itself, it will be a self-reciprocal function. This will be the idea. Okay. Right. Is all of you understand these ideas? These 4 to 5 problems are very, very important. Okay. Right. All the problems are similar to this way only. All of you copied that previous problems here? Yes. Okay.
Sir, one show the last slide, sir.
Okay. This part?
Yes, sir.
Okay.
Yes, sir. Please, sir.
Okay. These problems are very, very important and standard problems also. Standard problems also.
For exams, sir.
Huh?
For exams, sir.
For exams. In Fourier transform specifically, we have certain problems only. Again and again, it will be repeated. Okay. These are the problems based on the direct definition of Fourier transform and the inverse Fourier transform. Inverse Fourier transform. Then now we'll move on to some properties. Okay, properties. That is the thing we missed one day class, and we'll move on to that properties. Properties are very simple only, just a proof only. We can easily identify. Okay, with the help of that property, we can finish this session, today's session here. Okay. Move on to properties. Yes, already we have completed one property, linearity property. Linearity properties. Now we move on to more properties. Property number 2. Put properties. Property number 2. Shifting property. Name of the property is shifting property. If f of x equal to f of s, if f of x equal to f of s, Fourier transform of any function, Fourier transform of a function f is a function of s, then Fourier transform of f of x minus a. In x, you are giving the shift in the scale here, x minus x to x minus f of x minus a, origin, shift in the origin, x minus a, not a scale, origin, that is equal to, the result will be e power minus ias into f of s. E power minus ias into f of, like a Laplace transform, here is also the same type of idea. Fourier transform of f of x minus a, that is equal to e power minus ias f of s, or minus ias f of s. Proof is very simple, just to put x minus a is equal to y, that's all, the definition. By definition, proof, by definition, f of x equal to 1 by root of 2 pi, 1 by root of 2 pi, integral minus infinity infinity, f of x e power minus isx dx, f of x e power minus isx dx. That's equal to f of s. That's equal to f of s. Then Fourier transform of f of x minus a, Fourier transform f of x minus a, that is the thing we need. So instead of f of x, we replace the definition f of x minus a, 1 by root of, remaining things are as usual, 1 by root of 2 pi. Instead of f of x, f of x minus a, this is fixed kernel as usual, e power minus isx dx. Okay? Put x minus a is equal to y, x minus a is equal to y, then x is equal to a plus y, then dx is equal to dy. We are converting x to y only, x to 1, dx equal to dy. When x varies from minus infinity to infinity, x varies from minus infinity to infinity, and y is also varies from minus infinity to infinity. Y is also varies from minus infinity to infinity. 1030 then also. No. Right. Now substitute here x minus a is equal to y, f of y, e power minus is, x can be written as a plus y. This part over, this page over.
Yes.
Then substitute here f of x minus is 1 by root of 2 pi integral minus infinity f of y, x minus a is equal to y, e power minus is x now can be written as a plus y, x can be written as a plus y, x is a plus y, and dx becomes dy. 1 by root of 2 pi, 1 by root of 2 pi integral minus infinity to infinity f of y, e power minus ias, e power minus ias, e power minus isy, dy. As usual, integration is with respect to y. Take unnecessary term outside here. This is no y, no y involves. So take it outside here. E power minus ias. Remaining thing, right? That 1 by root of 2 pi integral minus infinity f of y, e power minus isy dy. Now it is like a Fourier transform definition. This whole part like a Fourier transform definition, 1 by root of 2 pi minus infinity f of y e power minus isy dy. F of y e power minus isy dy. F of x, Fourier transform definition, f of x e power minus isx dx. Here f of y e power minus isy dy. But only variable only changed here, but function is same function. Function is same function. Fourier transform f of y. But function is same, but already we noted that Fourier transform that f is f of s, function of s. Therefore, same function, therefore it is f of s. Therefore, f Fourier transform f of x minus a equal to e power minus as into f of s by the definition. Okay. Function is same, but only variable only we changed here. Right? Very just substitution only. Put x minus a is equal to y in this relation. That's all. Remaining things you can easily identify. I will move on to next property. This property over.
Yes.
Okay. Third one, change of scale property. Change of scale property. Change of scale property. If f of x equal to f of s, if f of x equal to f of s, then f of ax, f of ax equal to 1 by modulus of a, 1 by modulus of a function of s by a. F of x means s, f of ax means s by a, where a is not equal to 0. You are changing the scale x to ax form, x to ax, you are multiplying by a. Where a is not equal to 0, it may be negative or positive. A is not equal to 0 means a may be negative or positive. You are going to write like this. Okay. Yes, use the definition as usual. By definition, f of x equal to f of x 1 by root of 2 pi del minus between f of x equal minus asx dx f of s. This is as usual. This is definition of Fourier transform. Yeah, right. Now instead of f of x, we are going to put f of x in the proof. We are going to put that f of ax that is equal to 1 by root of 2 pi, 1 by root of 2 pi integral minus infinity f of ax e power minus asx dx, e power minus asx dx. Now put the substitution ax equal to y, ax equal to y as usual. Then x equal to y by a, dx equal to dy by a, dx equal to dy by a, dy by a. Okay. Then x varies from minus infinity to infinity, x varies from minus infinity to infinity, and y is also minus infinity to infinity, whether it is correct or not. Any condition we have to impose or not here. Huh? Anyone? If I put x equal to minus infinity, y is also minus infinity, x infinity, y is also infinity, whether it is correct or not, any condition we have to impose for this substitution. Anyone have the idea? Provided a is greater than 0. A is greater than 0 because a is a constant. Suppose a is greater than 0, only this limit is possible. Y varies from minus infinity to infinity, x varies from minus infinity to infinity, y varies from minus infinity to infinity. Yes, this is possible. Only the above limit is suitable only when a is greater than 0. A is greater than 0. A is greater than 0. Above limit is suitable only when a is greater than 0. Yes, okay. Therefore, 1 by root of 2 pi, limit is same limit we are going to put that minus infinity to infinity by considering a is greater than 0. F of y, putting ax equal to y. Putting ax equal to y. Here a f of y e power minus is x is equal to y by a, and dx equal to dy by a. Substitute. Now we club this a with s here, s by a and y, because in order to maintain with Fourier transform definition, we have to club a with 1, and 1 by a take it outside. 1 by a, 1 by root of 2 pi integral minus infinity f of y e power minus I s by a dy dy. 1 by a, it is like a Fourier transform definition f of s by a, 1 by a f of s by a, 1 by a f of s by a, function of s by a. Fourier transform definition minus infinity f of x e power minus isx dx form, same form, but instead of s here s by a is present. Therefore, function of s by a. Function is same function, only variable only changed here. Instead of f of x, we are using f of y. Function is, result will be a function of s, but instead of s here s by a is present. Therefore, s by a. Provided this condition only true for a is greater than 0. A is greater than. Correct? When a is less than 0, suppose a is less than 0, under ax equal to y, under this substitution, when we have x varies from minus infinity to infinity, when we have x varies from minus infinity to infinity, correspondingly y varies from plus infinity to minus infinity, and a is less than 0. A is less than 0, we can get change of the limit. Because a negative, a is negative, under this substitution we can get this one. Okay? But only remaining things are same, but only one different is plus to minus. Plus to minus, that is a substitution. This page over, this page over.
Four, sir.
Okay. Then when we put ax equal to y, a is less than 0 condition. A is less than 0 condition. Therefore, this f of ax equal to 1 by root of 2 pi into minus infinity f of ax e power minus asx becomes, this expression becomes plus to minus, plus infinity to minus infinity, plus to infinity minus infinity, f of y e power minus is, this x becomes y by a, dx becomes dy by a. The same substitutions, but only one change here. Right. Now already you know that this is for a is less than 0. A is less than 0. Now because of a is less than 0, this constant is less than 0, I will write this constant as a minus, I will take minus outside and with modulus symbol. With modulus, because of a is less than 0, suppose it may be minus 5 or minus 2 like that here. I will write that minus outside and then write 5, modulus of 5. In that manner we can, only positive part only I am going to write. I take minus outside. And 1 by root of 2 pi minus plus infinity to minus infinity, and remaining things are same. Right. Remaining things are same. Because of this minus I am taking outside here, because of this negative part I am taking minus outside. This minus change the order of the limit. This minus will change the order of the limit as minus 2 plus, minus v 2 plus 1. I will take that minus part changing the order of the limit. So 1 by modulus a, 1 by root of 2 pi minus v 3 plus f of I e power minus ir s by a y dy. For a is less than 0, since a is less than 0. Yes, this is like a Fourier transform definition. This is like a Fourier transform definition. Now you can ask a question, sir, what about this a? This a is a negative a only, no problem. I am not changing this a. This a is negative a only, there's no change. Therefore, this 1 by modulus a, remain things are Fourier transform definition, but instead of s by a. 1 by mod a, 1 by mod a, f of s by a. The result will be 1 by mod a, f of s by a. 1 by modulus of a, f of s by a. This is for a less than 0. A is less than 0. Here a is less than 0, but here a is positive a, you are going to consider in the outside. Because I am taking that minus for changing the order of the integration. Therefore, here only outside only positive a only, but inside it is negative a, no change. Therefore, when clubbing both a greater than 0, a less than 0, a greater than 0 also outside is positive. A greater than 0 also outside is positive a only. Here a greater than 0, no problem. Outside is positive. Therefore, positive a outside both a less than 0 or greater than 0. Therefore, generally you can put consider it for, hence for a is not equal to 0. It may be greater than 0 or less than 0. Hence for a is not equal to 0, we have Fourier transform f of ax equal to 1 by mod a, 1 by mod a f of s by Fourier transform f of ax equal to 1 by mod a f of s by 1 by mod a modulus of a f of s by. Correct? Well, if you understand here. Fourth property that I have shown in the screen, I think you can try yourself here. Fourth one, f of x is equal to f of s. Then f of e power iax f of x is equal to f of s minus a. f of e power iax f of x equal to f of s minus a function as well. Proof is just two line only. Just instead of f of x, here f of x e power iax, exponential is multiplied. Then exponential is multiplied with f of x e power iax, complex form of exponential e power iax. Then you club this both. This is function. This is definition kernel. You club these two I into minus I into s minus a form. Yes, the definition if you want to use means minus I, you have to take it outside exponential. For minus I s minus a x. That's all. Proof is just two line only. For Fourier transform f of x e power ix, Fourier transform f of x e power ix is equal to function s minus a. Correct? Just two line only. Based on the same idea, here, like in the previous result, we have exponential, complex form by exponential is multiplied. Now we have the statement of modulation. Another property is that fifth property, modulation theorem. Modulation theorem. Modulation theorem. This property and one more property only. That's all. Then we can complete. Modulation theorem. If f of x equal to f of s, then first subdivision f Fourier transform f of x cos ax. Fourier transform f of x cos ax equal to, then cosine is multiplied. F of x cos ax equal to 1 by 2 of f of s minus a plus f of s plus a. F of s minus a plus f of s minus a. S plus a. Similarly, subdivision number 2, when sine is multiplied. Fourier transform f of x sin ax. Fourier transform f of x sin ax equal to 1 by 2 of f of s minus a minus f of s plus a. Minus f of s plus a. Okay? Right. Right. Just you replace f of x by f of x cos ax. Then write cos as an exponential form, e power ax plus e power minus ax by 2. Sin ax as a similarly e power ax minus e power minus ax by 2. That's right definition. And replace f of x by f of x cos ax, f of x by f of x cos ax, e power minus ax. Then write cos ax as a e power ax plus e power minus ax by 2 exponential form. Then club this exponential, these two exponential, and club these two exponential, and separate the integration for this addition. For this addition, two integrations for this addition. E power minus I minus, you have to take it commonly, minus I s minus a, and then this is minus I s plus a. That's all. This 1 by 2, take it commonly, 1 by 2. One by two, take it commonly. Just a split and then blah. Or yes, this is Fourier transform definition, but instead of s minus a. Fourier transform definition instead of s plus a. So 1 by 2 of s plus a, function of s minus a plus function of s plus a. That's all. Or this page copied. Or that's all. Then f of x cos x equal to 1 by 2 of. Similarly, you can try for sin ax by writing sin ax as a e power ax minus e power minus ax by 2y. You know? That's also possible. Then last property, with this we can complete the result here. Last property. If f of x equal to f of s, f of x equal to f of s, then Fourier transform of x power n f of x. Fourier transform x power n f of. When with f of x, a polynomial of x is multiplied, x power n multiplied. F of x power n f of x equal to I power n d power n by ds power n of f of s. I power n d power n by ds power n of f of s. The previous two properties are when exponential is multiplied and then cosine sine is multiplied. Now algebraic polynomial of x is multiplied. X power n f of x. F of x equal to I power n ds. We are going to prove this result with the help of right hand side, like Laplace transform technique. Also, here is also we are going to prove with the help of right hand side. Right hand side, you take it as f of s as the definition. This definition of Fourier transform, f of s as 1 by root of 2 pi integral minus infinity to infinity f of x e power minus I s x dx. This is f of s. We are going to take this left to right, right to left, right to left. F of s is equal to so on. You take proof, you write the definition and take it as f of s. I will write right to left relation here. F of x is equal to 1 by root of 2 pi integral minus infinity to infinity f of x e power minus I s x. Definition of Fourier transform only. This is definition of Fourier transform. Now differentiate the whole right both sides with respect to s d by ds f of s. Equal to d by ds of 1 by root of 2 pi integral minus infinity to infinity f of x e power minus I s x dx. F of x e power minus I s x dx. Then this derivative moves inside the integration as a partial derivative. This is Leibniz rule. 1 by root of 2 pi minus infinity moves inside the integration as a partial derivative, dou by dou s of the whole function, dou by dou s of that remaining functions. Okay? But here x, here only s is present. Therefore, differentiate with respect to s for f of x e power minus I s x. Derivative is e power minus I s x only, but with respect to s means minus ix you can get, minus ix. Now you can club this x with f of x, I you take it outside, I you take it outside here, or minus I take it outside, 1 by root of 2 pi minus infinity x f of x, you can club x here, e power minus I s x here. Please take it as equation number 2 because we need further differentiation. So keep this relation as it is. Right. I will take this minus I left side, minus 1 by I, d by ds of f of s. This is Fourier transform definition. This whole thing is Fourier transform definition. Instead of x, instead of f of x, here x into f of x is Fourier transform x into f of x. Okay, right. That's all. Then Fourier transform x f of x equal to, everyone know that 1 by I is minus I. You multiply by conjugate, then you can get 1 by I is minus I, minus plus I again. So plus I d by ds f of s. This is one result. No. But consecutively you have to prove it is x f of x. Similarly, you have to try for x square f of x, x cube f of x, and then move out to here. Therefore, in order to get x square f of x, again differentiate this relation, equation number 2, with respect to s. Okay. Similarly, differentiate equation 2 again with respect to s. We have differentiate equation number 2 again with respect to s. We have, what do you have? Left side is d square by ds square f of s. Right side is minus s minus I 1 by root of 2 pi. Definition with respect to s moves inside the integration as a dou by dou s, x f of x equal minus I s x dx. X f of x equal minus I s x dx. But here only s is here. s. No remaining things are x only. Or you can get e power minus ix derivative is e power minus ix, but one more minus ix. That x you can club here. That minus I here you can club. D square by ds square. That minus ix you are getting one more minus ix you are getting here. Minus I 1 by root of 2 pi. I will glove this minus I and minus I here, minus I whole square, because power 2 we have to write here, therefore we keep minus I whole square as it is. No need to write that value, because we are going to generalize the result here. Therefore no need to write the value, you keep minus I whole square, 1 by root of 2 by minus infinity x square f of x. This x square f of x e power minus I. This is Fourier transform definition. This is totally a Fourier transform definition of x square f of x. Fourier transform x square f of x. I will take this minus I left side here, 1 by minus I whole square, 1 by minus I whole square. I will write this 1 by minus I whole square as a 1 by minus I whole square. You can also write like this. We have 1 square and minus I whole square. 1 square minus I whole square. Therefore, I will take 1 by minus I whole square. But 1 by minus I, 1 by I is minus I. Already a minus plus. Or can write I whole square. Oh, I whole square. 1 by I is minus I. Already a minus is there. Therefore, you can write plus I. So plus I. Power 2 is as it is. Power 2 as it is. I square d square by d square f of s. Right, left side is as usual. Or is f of x square f of x. F of x square f of x. Therefore, Fourier transform x square f of x equal to I square d square by d square f of s. Fourier transform x square f of x equal to I square d square by d square f of x. The similar way, you see the previous result. Fourier transform x f of x means I power 1 d by d square. Fourier transform x square f of x means I power 2 d square by d square. So Fourier transform x cube means x cube f of x means I cube d cube by d cube f of x. I cube. In generally, if you proceed like that, x power n f of x means I power n d power n by ds power n f of x. D power n by ds power n of. Or if you proceed successively, you get Fourier transform x power n f of x equal to I power n d power n by ds power n of I power n d power n by ds power n of. Okay, we will have some more properties, convolution theorem and Parseval's identity we have further. We will see in the next class. Up to this, we have the some simple properties. I think all of you understand today's idea. Then we can complete this session also. Okay, thank you. If you have any doubt, you can ask. Otherwise, you can leave. Thank you.